Greetings from the Engineers League. This video was brought to you by Team 3 from Section 05. Did you know that you are always exposed to hazards in workplace, school, university, street, even inside your own shelter, home? According to the National Safety Council, 53.6% of all injury-involved accidents occur at home, which is a proof that many possible hazards are at home without us being aware.
People nowadays tend to ignore their safety and health due to life's fast pace. The seriousness of safety and health in daily life among society must be embraced, and it is our duty as UTM students to improve safety and health conditions and raise awareness about this topic. And for this very reason, the Safety and Health for All 2021 competition has been organized.
The competition had 3 stages throughout the semester. The overall objectives were to learn about sustainable development and how it is related to safety and health, to perform a study on the severity of safety and health problems at home and surrounding areas,
to benchmark safety and health conditions in Malaysia compared to other countries, to classify many of the possible hazards from different activities by a college student and a Malaysia family and quantify the impact of those hazards, and to formulate an engineering solution that reduces the risk of the high-risk hazard at home.
When we were introduced to each stage's problem statement, we used to write all the new terms that we wanted to learn about under the Learning Issues column inside the problem identification table. After that, we used to do detailed research on these terms and write about them in the literature review section in our report.
In stage 1, we discussed sustainable development and sustainable development goals, benchmarking, safety and health, and occupational safety and health.
For stage 2, we look into categories of safety and health hazard, standard of safety and health, hierarchy table, and data collection.
In stage 3, we have learned about engineering solutions and risk reduction.
Moving to the methodologies we follow, in stage 1, we use a variety of books and journal articles and other reliable sources to find the information and data for benchmarking.
During stage 2, we use our observation on the hazard for 1 week, and we have distributed Google Form to collect data from other people also.
In terms of stage 3, based on the data collection and the MATLAB program, we chose kitchen fires as the hazard that we want to find an engineering solution for. Next, the phase of researching and solving contradictions has started. There were many issues with the idea proposed in terms of price, impact on the environment, size, and the materials used. Everything was taken into consideration. TRIZ was used to solve some of the contradictions also.
From the results from stage 1, the most at-risk country during COVID-19 pandemic is United Kingdom. In the construction accident aspect, the Netherlands has the highest rate. Meanwhile, Malaysia is at the top of road accidents.
Through stage 2, we have analyzed the collected data from many different aspects. For example, the observation of our team members was from different cities such as Kelantan, Johor Bahru, Kuala Lumpur, and Ajman in the United Arab Emirates.
For stage 3, a MATLAB program was created to assess and calculate the risk for the selected activities. It also suggests control measures to reduce the risk level. It is designed for 3 areas at home: kitchen, bathroom, and the living room. The program is flexible and user-friendly, and here is a short demonstration on the program. This is a view of what the program looks like. We choose cooking as the activity and enter number 5 for the frequency, as cooking is a very common activity in our daily life. The risk is very high as shown in the table.
Cooking is a common activity in daily life, which means that it has a high frequency. Therefore, the likelihood of the fire inside houses is also high, thus has a high risk level. Apart from the recommended control measures, an engineering solution must be proposed to reduce risk of fire inside the house.
In the incident of fire, it is really dangerous for any non-specialized individuals to approach the fire even if they have a fire extinguisher. In worst scenarios, a fire could occur while the people inside the house are asleep.
Consequently, the best solution is an automated machine to put the fire out automatically. Therefore, the Firefighting Capsule Shooter, or FFCS, was proposed. As the name of the idea describes, the FFCS is a device that's attached to the ceiling, usually in the kitchen because fire is more common inside it, and shoots firefighting capsules that are able to distinguish the fire. Its ability for the 360 degrees rotation is due to the base that's similar to the CCTV camera's base.
FFCS comes with a smoke alarm with a camera. It detects the fire using the smoke alarm and locates it using the camera. It is programmed to rotate and aim the opening towards the fire and shoot the capsule on the fire.
FFCS fits for 3 capsules and can be refilled once the capsules run out. The capsule shell is made of polystyrene, and the fire extinguishing substance inside it is a dry chemical named monoammonium phosphate, or MAP. The capsule's life is up to 10 years. Once the capsule is in contact with the flames, and within 3 seconds, the capsule activates and triggers a mild explosion that spreads the MAP and extinguishes the fire instantly.
The FFCS can prove its ability to extinguish fires inside the kitchen scientifically, starting with the MAP. This dry chemical powder is able to extinguish fires by forming a thin layer above the materials that are burning, and thus cut off the oxygen supply to the fire, causing it to put out. Another aspect that's needed to be considered is the capsule launching velocity. When the capsule is launched, it takes the path of a horizontal projectile. To make sure that the capsule is dropped directly on the fire, the FFCS calculates the horizontal distance to the fire using the camera. Then it calculates what is the launching velocity required.
The FFCS is sustainable and complies with the 3 pillars of sustainability. The map used inside the capsule is non-toxic, environmentally friendly, and easy to clean. Each capsule costs 19 ringgit. The throwing machine costs 70 ringgit. The rotating machine base costs 20 ringgit. And the smoke detector with camera costs 65 ringgit respectively. The prices was determined based on the average price in the market that is affordable and has high quality. And the final cost analysis find that the total price of the firefighting capsule is 174 ringgit. After the economic analysis was done, it is decided to proceed with the solution as it worth the price and sustain it.
In conclusion, after these 3 stages, many things have been achieved. The safety and health situation was studied very deeply in many areas around the world through benchmarking and especially in Malaysia, and it has been investigated from many different aspects.
In addition, sustainable development and sustainable development goals have been explored and related to the study.
Also, many possible hazards that come from daily activities by a college student and a Malaysian family were identified and classified depending on the categories of hazard.
Moreover, the impact of these hazards has been quantified using the concepts of likelihood, severity, and risk, which was adopted by DOSH Malaysia, and the data has been collected and listed in a hierarchy table.
Besides, safety and health conditions and measures in Malaysia have been benchmarked with those in other countries such as the United Arab Emirates, the United States, and Indonesia.
What is more, the awareness of the subject has been increased dramatically after conducting the study, which is one of the most important objectives.
Finally, the engineering solution, FFCS, has been created to reduce the hazard of fire inside the house, save life, and benefit the humanity.
By that, we conclude the 3 stages of Safety and Health for All 2021 competition. Hope you enjoyed. Thank you and see you in the next one.